Hello everyone. In this video, we are going to talk about primary keys and the level of data and how to use Python to spot them during exploratory data analysis. So what exactly is a primary key? It's the column or set of columns that uniquely identifies every single row in a table. A good primary key follows three simple rules. It's never empty, every value is unique, and there's only one of them per table. Let's see these rules in action. Rule 1. No part of the key can be empty. The moment a key field goes missing, the row can no longer be identified. So, a single null breaks the key instantly. Rule 2. The whole combination has to be unique. Here, the same student, course, and term show up twice. A collision. When two rows share the same key, we simply can't tell them apart. And rule 3. A table has exactly one primary key, even when it spans several columns. On its own, each column repeats, but put student, course, and term together and they form a single composite key. Now, why does this matter? Watch a merge on a bad key. Customer C7 has duplicated 4 times. So, 2 payments span out into 8 rows. Every total silently balloons. 8 rows, but only 2 real payments. So, fix the grain before you merge. So, how do you actually find the primary key? Usually, the data dictionary just tells you. But what if there isn't one? No documentation, no prior knowledge of data. That's where Python can help. We can develop a code that checks every column combination until only student, course, and term remain, the primary key. Coming to the practical side of the things, we'll start by importing a data set that I have created to illustrate this point. So we'll do that by creating this construct and reading the file through read.xl into a pandas data frame, post which I am attaching a flag column. It's a dummy column which I am assigning a value of 1. Why this is being done will be evident in the next part of the video. I'll just run it to showcase what the data frame actually looks like. So over here you can see it has 1000 rows and total of 11 columns. So be mindful of the fact that we actually need only these 10 columns. 11 is coming due to this additional one which I've created here. But looking at the data, it appears to be some sort of like a sales data for some brand of garment, wherein you see the sales information in terms of the age of the brand, some sort of maybe score given by the customer purchases, the quantity and price, and how much of that garment is being sold by each store, each department in the region, what's the code, the color and the size, and some sort of status. So this appears to be sales information data. Now, in order for us to identify what is the primary key for this data set, what we'll do is we'll start by using the 3 rules. So first of them was we have to check which of the columns in the data frame are there which have missing values. So to do that, we'll first create a list of candidate columns over here. So as you can see, I've removed this flag column that I've created here. And what I am doing is in the next construct, I am creating a column, a list which calls for columns with nulls, and it is being checked through this construct where each of the columns are being iteratively pulled and checked if any of the values in these columns is null, and that is being done through this any functionality. What this will do is after this is run, it will flag out any column which has a single, at least one missing value inside them. So if I run this, what we do see is first the list of all the candidate columns, which is nothing but all the columns which were present over here, followed by the columns which is has identified as having at least one missing or null values. So let's check it over here. I'll put them one by one and we'll see. So this is the color, and you see for rows 29, 35, 47, there are all null values along with the other non-null values for other columns. Similarly, if I do this for size, so you can see 293, 105, 149, there are nulls. And again, if I do for status, I'll see 8, 14, 32, 33. Now, just to be sure, let's also check for this column to see if it shows any. Let me just take one more. So as you can see, this one only catches the columns which are null and doesn't catch the columns which does not have any null values. So since we have these three having at least one null value, we will eliminate them from our list of candidates and then we'll update the list over here. When I run this, it removes the color, size, and status columns and just keeps the rest of them as candidates. Now, the meat of this whole analysis is this portion of the code. What it does is, first it takes the help of a very useful package in Python called iter-tools, and it imports one of the functionalities called combinations. So what it does over here is, out of all of these columns present over here, it will create a one column combination, two column, three column, four column combinations, so that we can push them into this second looping construct over here one by one and check for this condition. So what does this condition say? And this is where this flag which we created earlier is being used. What does it say? It says, if I just take, let's say, region to start with, and I group by all the data and count the number of records by region, do I get any set of records in the output, which is being tested by this second line? If the answer is yes, then that does not qualify as a primary key, because that in a sense says that for that specific column, you have more than one repeating values. So you keep doing this for multiple combinations, and what you end up seeing is which one is your column. So over here, you can see that when I run this, it picks out region, department, and code. So this is the code that you can actually use on data sets to identify which one of the columns are your primary keys. Now, this one is a very simplistic example, and maybe you can do it manually also, but think about a situation where this spans to 50, 100, 200, 500 columns. Then it really becomes a difficult job to do that manually. But once you have this code, you can continue to do that in the same way. As part of the validation of the output that we got after running the code on what was our primary key, which was the set of these three columns, let's do the validation on the Excel. So this is the same Excel which was read into a pandas data frame in the previous code. So it has the same 10 columns and 1000 rows. And if you remember, it has the same fields as well. So how we'll check this is, we will create a pivot on this. And then what we'll do is we'll put these columns over here. Change this to count. So you can see for each of these categories in a region, it has 100 records. Now, if I continue to drop the other columns, so first let me change the design of this. Let me stop the subtotals, change the layout, make it into a tabular form, and also repeat the labels. So when I drop the department, the count has become 1010. And then if I drop the code also, it was the third piece of this whole primary key. This is what it becomes. So now if I copy this into a new tab, So now if I apply filter, you can see it has only one row in each of the columns, against each of these columns. So that's basically how we can check that whatever the output the code has produced, was it correct or not. Thanks for watching this video. I hope you enjoyed watching it. If you found this video helpful and learned something new, then please like and share this video and subscribe to my channel. See you in the next video.